Welcome to my presentation. In this presentation, let us look at some applications related to vectors in 3 dimensions. In here, we want to find the area of a parallelogram and the two sides of the parallelogram are given to us. Let me write that here. The two sides are given to us in terms of vectors, and the vector A is given to us as 3, 2, -1. We can also express this in terms of components of vectors as 3i plus 2j minus k, and I have represented that on the graph here. I've got the graph started so that way I need not have to waste time, so I can have the figure and then I can point the figure out as I explain. So we're going to travel 3 units on the positive x-axis, and then we're going to travel 2 units on the positive y-axis, and we're going to travel 1 negative unit on the negative y-axis. So you're going down that way. Therefore, I put an arrow there, I put a small red circle there, and I have connected it with this green line starting from the origin. And that is the vector A, and the vector A is represented as 3i plus 2j minus k. Similarly, there is a vector B which is given to us. This is the other side, another side of the parallelogram, and it is given to us in terms of R3 spaces 1, 2, and 3, and we can express this in terms of components of a vector as 1i or just I plus 2j plus 3k, and I have represented this on the graph as follows. We are going to travel 1 positive unit on the positive x-axis. We're going to travel 2 positive units on the positive y-axis, and we're going to travel 3 units on the positive z-axis. So therefore, this is the red point where it is going to terminate, and I have connected it from the origin to the point to the red point there as a vector, and the terminal point there is going to be 3, 2, -1, and I've indicated that by a green line, and that green line is this vector B, which is B is I plus 2j plus 3k. Now that we have identified both the vectors as sides of a parallelogram, we will try to complete this figure and then show you how we can find the area of this parallelogram. I'm going to draw a parallel line from the terminal point of B, a parallel line to vector A, which is going to look like that. And then I'm going to start from the terminal point of vector A and then draw a parallel line to vector B, which is going to look like that. And therefore, we have a parallelogram in here, and the way we want to look at it is we want to find the area of this hatched region. We want to find the area of that hatched region, and that is what we are looking at. A parallelogram is a 4-sided figure which looks similar to a rectangle, but it looks like a skewed rectangle. We have 2 long sides, we have 2 short sides. The opposite angles are equal in a parallelogram. We want to find the area of this parallelogram, and the sides of this parallelogram are given to us in terms of vectors as vector A and vector B. From our properties of vectors, we know that the area of a parallelogram is given to us as vector A cross vector B, and we're going to take the magnitude of that product. So first things first, let us try to find A cross B. We know the vectors, we know the components of vectors A and B. The components of vector A and B are given to us 3i plus 2j minus k. Those are the components of vector A, and we're going to cross that with vector B, which is I plus 2j plus 3k, and to find the dot product, to find the cross product, we're going to use determinants like the way we did in the past, and the way to do that is as follows: I, j, k. We write I, j, k as the first row, then when we write the coefficients of I, j, and k for vectors a and b just below this. The coefficient of I for vector a is 3, the coefficient of j is 2, the coefficient of k is -1, and the coefficient of I for vector b is 1, the coefficient for vector j is 2, then the coefficient for vector k is 3. We find the determinant of this, and once we get that, we'll find the magnitude of that product. So in here, we want to travel along the first row, and the sign convention we're going to follow is positive, negative, positive. And when we do that, this is how we're going to expand this. We're going to start with I, and we take the minor of that, which is 2, -1, 2, and 3, and then minus j. The minor of that is 3, -1, 1, 3, and then plus k. The minor of that is 3, 2, 1, 2. Therefore, when we expand this, it is going to be I, 2 times 3 is 6, minus 2 times -1 is -2, times negative will be positive, so therefore plus 2, minus j times 3 is 9, minus 1 times -1 is -1, times negative will be +1, plus k times 3 times 2 is 6, minus 1 times 2 is 2. So we got all the simplification process of the determinants there. So 6 plus 2 is 8i, 9 plus 1 is 10, minus 10j, and then 6 minus 2 is 4, therefore 4k. So we got the product of A cross B. We want to find the magnitude of that, and that is going to give us the area of the parallelogram. The area is the magnitude of the cross product between vector A and vector B, like that. And to do that, we're going to take the components of I of vector A of this product, and then do it this way: 8 raised to the power of 2 plus -10 raised to the power of 2 plus 4 raised to the power of 2. And when we expand this, we should be able to get the area. This is going to be equal to 8 squared is 64, plus 10 squared is 100, plus 4 squared is 16. Therefore, when we simplify this, 64 plus 100 plus 16 is going to be equal to 180. And as we know, 180 I can write as 9 times 2 times 100. 9 times 2 is 18. 18 times 100 is 180. The reason I wrote it this way is because I know that square root of 9 is 3, and the square root of 10, square root of 100 is 10, and then 2 is not a perfect square, therefore we will leave it under the radical term. So therefore I can write this one as 3 times 10 is 30, square root of 2. So therefore the area of the parallelogram, which has sides given to us in terms of vectors, is equal to 30 square root of 2. If I were to draw a figure in here, and if this is the parallelogram, and if I were to say one of the sides is given to us as vector A, and if these are given to us as 3i plus 2j minus k, and if this side is given to us as vector B, and if the components of those are I plus 2j plus 3k, then we're going to come in here and then say the area of this parallelogram is given to us is equal to 30 square root of 2, like that. Okay? So this is the way we can find the area of a parallelogram using vectors in 3 dimensions, using vectors and using determinants. We have used a lot of information here to find the area of these types of geometric figures. In my next presentation, we shall look at some more examples related to applications of vectors in 3 dimensions.